Hi guys! In this lesson we're going to talk about another strategy for factoring quadratic trinomials when a doesn't equal 1. So the method we learned last week, still viable, great strategy. It's just less traditional and it's kind of tedious to make all those tic-tac-toe squares. So if you remember, we're starting our unit here on quadratics. A quadratic is an expression, an equation, or a function where the highest exponent or power is 2. So remember, an expression is kind of like a mathematical phrase versus an equation or a function is more like a mathematical sentence. An equation would be set equal to some value. A function is going to be set equal to f of x or p of x or just plain old y. So in this example, we are going to start in the same place that we started last week. We're going to say, okay, a doesn't equal 1, so I can't just jump to fast factoring. I need to find factors of 12 with a sum of 7. So I know those are 3 and 4. So if I were to break apart that 7, I could break the 7x into 4x and 3x, or vice versa. I know in every line that I make, I need to have an equal sign. And then I look at the first two terms and I say, what is the GCF between 2x squared and 4x? 2x. And then what is the GCF between 3x and 6? 3. So now if you look at this term and this term, remember a term is a mathematical expression separated by either addition or subtraction. The GCF between each of these terms is going to be x plus 2 because that's what they have in common. If what's in parentheses isn't identical, then you've done something wrong. Go backwards, see what error you've made. So my final factored expression is x plus 2, 2x plus 3. So if we go up here, this is called standard form, and this is called factored form, and they are equivalent expressions. So they can be used interchangeably to find different key features. So take a second, ask yourself, what is AC, what is B, and what are factors of AC with the sum of B? My factors of AC with a sum of B would be negative 12 and negative 1. So I can break my negative 13x into negative 12x and negative 1x. And then I'm going to look at my first two terms and say, what is my GCF? And then I'm going to look at my second two terms and say, what is the GCF? Now, between each of these two terms, what is the GCF? What is shared by each of these terms? So the GCF is going to be x minus 3. And then the first term would have 4x left over, and the second term would have a negative 1 left over. So again, this first line that we started with is called standard form. And this last line that we ended in is called factored form. Okay, so in this example, ask yourself, what is AC? What is B? And what are factors of AC with the sum of b. So my AC is negative 30. My b is 13. So factors of negative 30 with a sum of 13 are 15 and negative 2. So I'm going to break my 13 apart into 15x and negative 2x. I'm going to leave my a and c terms alone. Remember, that's very similar to the box method strategy. We left a, the very first term alone, the very last term alone stuck in the box. And then we broke up that middle term into two manageable chunks. So if you look at the first two terms, the GCF is 3x. And if you look at the second two terms, the GCF is just negative 1. So on this line, I asked myself, what is the GCF between my first term and my second term? So the GCF here is 2x. Oops. And if I look, I can find my error. There was a sign error right there. So it's 2x plus 5 is the GCF between the two terms. So my standard form that I started with was 6x squared plus 13x minus 5. And my factored form that I ended with is 2x plus 5, 3x minus 1. Okay, example 4. What is AC? What is B? And what are factors of AC that add to equal B? So AC is negative 36, B is 0. And factors of negative 36 that add to equal 0 are 6 and negative 6. So really what I'm doing is I'm taking 0x and I'm breaking it into 6x and negative 6x. Always have an equal sign at the beginning. It shows equality from one line to the next. And then I'm going to say the GCF between 9x squared and 6x is 3x. And the GCF between negative 6x and negative 4 is negative 2. And then on this line, I have to ask myself, what is the GCF between the first term and the second term? So the GCF here is 3x plus 2. So what's my factored form for this original standard form? So my end answer is going to be 3x plus 2, 3x minus 2. This is standard form. And this at the end is factored form. So this is my handy dandy little flowchart. This flowchart will be extended on as the year goes on. Right now we're just talking about quadratics, polynomials with the highest degree of 2. But we're going to talk about other polynomials with higher degrees as the year goes on. So step 1 to factoring. Always, always, always factor out any GCFs first. This is absolutely essential to completely factoring. Step 2. Ask yourself, how many terms are in the polynomial? Are there 2 terms? Are there 3 terms? There'll be more terms later, but for now, just 2 or 3. If there are 2 terms, ask yourself, are both terms perfect squares? And are they related by subtraction? If yes, use the difference of squares formula. Or do what we did in the last example. Just find factors of AC that add to equal B. If they aren't both perfect squares and they aren't related by subtraction, you're done. You factored everything you could. Or maybe you didn't factor anything at all and it's just not factorable. So now to the right-hand side. If there are 3 terms in your polynomial, ask yourself, does A equal 1? If A does, then fast factor by finding factors of C with the sum of B. This is what we did in all 75 of those questions that almost became second nature. If A equals 1, there is no reason to use a box method or a grouping strategy like we're learning today. It's going to be way more work than is necessary. Not wrong. You could use those strategies, but much more work, much more tedious than I would ever intend to assign you if I was giving you 75 questions. If A doesn't equal 1, though, use the box method like we learned last week, or this AC test that we're talking about today, to find factors of AC with the sum of B. So, step 1. Do I have a GCF? In this case I do. My GCF is 3. So I'm going to pull out my GCF. There can be major benefits to pulling out a GCF. So for instance, in this case, when I went ahead and pulled out that GCF of 3, I was able to see that what I was left with had an A term of just 1. So now I can just fast factor. Factors of 12 with a sum of -7. Much less work than boxing or using the AC test to group. Again, look at this example and say, do I have a GCF? Just like we did way last Monday when we first started factoring. So look at all these. They're all divisible by 5. They all have an x in them. So 2x squared plus 3x minus 9. I like to think of that 5x as like a bench warmer. Part of the team, important. Don't leave him at McDonald's after the game. Don't forget about him. He's got to live out there in the front all along. Every line you make, there's going to be a 5x at the front. But you can ignore him while you're factoring what's left over. So we're going to look for factors of A times C. Oops, got the C in my AC. Factors of AC with the sum of B. So 6 and -3. And then I'm just going to say, okay, 2x squared plus 6x minus 3x minus 9. GCF between 2x squared and 6x is 2x. GCF between -3x and -9 is -3. Don't forget that bench warmer. And I say, okay, what's common between these two terms is x plus 3. So then I have x plus 3, 2x minus 3. So try these. Look at each of these examples and see if you can factor them completely. It's a very essential adverb. Our essential adverb is completely. So factor completely. Okay. So A. I am going to be looking for factors of AC with a sum of negative 12. So my factors are negative 10 and negative 2. So I'm breaking my negative 12x apart into negative 10x and negative 2x. And now I'm taking what I have left and I'm pulling out GCFs out of each of the two chunks, each half. This is called grouping. So my final factored form answer is 5x minus 2 and x minus 2. Next one. Part B, I'm looking for factors of negative 36 with a sum of 5, so 9 and negative 4. The GCF of the first two terms is 3x. The GCF of the second two terms is negative 2. So my final answer is 2x plus 3, 3x minus 2. Okay, next problem. Problem C. So mentally, and I guess I haven't verbalized it, in each of these problems I'm always saying, do I have a GCF? So when I looked to looked to C, I noticed that 7 was a GCF of each of these three terms. So I'm going to pull out my GCF of 7. And I'm going to ask myself, what are factors of negative 3 that add to equal 2? 3 and negative 1. And I'm done. I didn't have to box or group because once I pulled that GCF out, what I was left with just had an A term of 1. Last problem. Last problem. Just like with everything, I always ask myself, what is my GCF? And in this case, my GCF is 25. So now that I've pulled out that 25, I'm just looking for factors of negative 4 with a sum of 0.